Hello, my name is Andrew Grant, and in this video we will be looking at the separation of concerns and C++ modules. This video is part of a small series looking at using C++ modules in a sort of real-world environment. Links to the other videos and to the GitHub repository are in the description. All the examples utilize Microsoft Visual Studio 2022 on Windows 11. This is the common entry file we'll be using throughout this brief overview. It'll not change from project to project. As you can see, it starts with the import stud statement. This is simply to enable the use of any part of the standard library not already included by the export of the standard library from any other module. If it's not required, the compiler will just completely ignore it. This is followed by an import of a module, the identifier of which varies according to whichever library we're looking at. We then have the entry function, complete with a bit of what you might call test code. For all the examples in this video, I've created a library project for each separation of concerns concept. Anyway, we'll start with an ordinary common garden module, just so we know where we're coming from. We'll start with the usual export module with the module identifier, from which we do an export and an import of the standard library. This means import the standard library and then make it available for export. This is followed by the public interface for the module, the export namespace, which in all instances will be the word hello. And into this we'll pop a class, which will carry the identifier hello to whom, with the private access area at the top and the public access below it. Modules, as you'll discover, do like everything to be declared and defined before use. And it's always a good idea to compile a library in debug and release modes. Before we can use any library, we need to reference it from the entry startup project. So using the startup project reference, we select the correct project. In our case, we will also deselect the other projects just to avoid collisions. In the entry file, you import the relevant module. As you can see, to save a bit of time, I've just commented out the imports we don't need just now. Now that we've seen the standard single module, let's create a separation of concerns which utilizes the private partition available with primary modules. Here we can see the class looks like a standard header file declaration. This is in the public interface area. Below the public exported namespace we have the private partition, the demarcation line being the text module : private finished off with a semicolon. The section is completely private and is not available outside of this module. It is in this section that you pop in the definitions for the object, functions and the constructor. It's important to remember to write in the definitions in the order they're declared in the class. As before, we'll compile in both debug and release mode and then run the application. And we'll add a reference to the new library with the test application. Compile and run the application and all should be well. Now we'll have a look at using a separate definition file, akin to a traditional definition file. Using the module interface as a traditional style object declaration, we'll create a definition file in a separate folder below the module folder. We'll name the folder definition, Pascal case, and the definition file single source file.cpp, again Pascal case, the module itself being called single source file.ixx. Into the definition file we'll pop in the required definitions. The difference between a module definition file and a traditional definition file is the use of the keyword module, followed by the module identifier at the top, and this is followed by an import stud. Do not attempt to export from this file. It leads to an amazing array of errors, warnings, and occasionally communications you can actually discern the meaning of. And the IntelliSense functionality will frequently request you change a function to a static function. Don't. Modules are not big on the concept of static functions. And compile the project as usual in debug and release modes. And then do the usual add reference, import the library module and compile the main project in both debug and release modes. And then using the terminal, run the application and ensure that it works as intended. And now we'll venture into something a bit more ambitious and more akin to a normal project structure, like what you should find out there in the real world, or at least what should be out there in the real world. We'll start by having a quick peer at the project structure. As you can see, we have a mix of definition files and modules. These files are all located within the private folder, simply because they are private. The module containing the class declaration now imports a submodule, mutable. It's the colon before the module identifier that informs you that the imported module is a submodule of this, the primary module. Think hash includer supporting object you've written. The other change is the constant variables are gone, and the mutable variable who, with a trailing underscore, is now a unique pointer of type mutable value. This is where the mutable submodule is being utilized. We'll have a quick peer at the mutable module next. And you might also notice there's a lot less use of the auto keyword. This is mostly because of the use of the submodule mutable and the need by modules for absolute clarity in the returning data types of functions. Just for fun, we'll place a private section in this module, which is the primary module for this library, just so you can see how it works. This private section contains the definition of the getter function, greetings, from the hello to whom class. As you can see, you can import other modules into this section. This is about the only place where you can do this. We'll pry open the immutable module in a minute or two. But first we'll look at the mutable module. This is a submodule, which you can gather simply because it has an IXX extension, and it has an identifier tied to the primary module. The identifier for this module is multiple files, module identifier, which in this case is mutable. This quite literally ties it to the multiple files module, the primary module. It's probably worth mentioning that you cannot derive another module from this module, simply because this is a submodule, and you really cannot use this module elsewhere. Basically, this module is only available within this library. But because this is a module, the namespace needs to be exported, otherwise it's not publicly available at all. Here we have the immutable module. Unlike the mutable module, this is an independent module. It's not tied to the primary module at all. You can see this because the module identifier does not have any other module identifier before it. This enables its use outside of the library, though this is really not recommended at all. It would be better to create a separate dedicated library for this sort of thing. However, let's head back to the code. The first namespace area, the const variables namespace, is not exported, nor is it desirable for it to be exportable. It therefore exists only within this module. The exported namespace, immutable, makes the contained functionality available to the users of this library. And here we have the first of the definitions separated out for the hello to whom class. This, the constructor, is given its own definition file. As you can see, this file does not include an export statement anywhere, as an import stud, but you can't export from this file. As I've said before, you'll get some very strange errors if you try to. The first line is a statement telling all and sundry that this file belongs to the primary module, multiple files. Think hash include the declaration header file, with the next line informing that it imports the submodule mutable. Again, think hash include a custom header file. A general rule of thumb is that if you are using something from a named module, import the relevant module. Back to the code. I found it best to use the fully qualified namespace for any imported namespace, particularly when implementing the definitions. Popping an encompassing namespace seems to cause a few hiccups in the compilation and linking. Not too sure why, but you get the same missteps if you utilize a using namespace quantifier. Now we have the setter in its own definition file. This imports both the submodule mutable and the module immutable, and utilizes the fully qualified namespace to enable functionality. The add exclamation doesn't need to use the fully qualified namespace, simply because the setter and the add exclamation function are part of the same namespace. And that's literally all one can say about it that's not already been stated. and the add exclamation function that adds an exclamation onto the end of the input string if required. As with the setter, it imports both the submodule mutable and the independent module immutable, and as before, it utilizes the fully qualified namespace to enable the desired functionality. The construct greetings function, which quite literally constructs the greetings we wish to convey, and will rely on the compiler to determine the correct implementation being returned to the caller. And then we do the normal add a reference to the main application, change the imported module, and compile in both debug and release. And after successful compilation, we'll run and test the application to verify it works. As you change the imported modules, you may quite possibly come across this type of error, where the entry application cannot find or does not recognize some essential elements from the imported module. It's annoying, but the fix, thankfully, is quite simple. Right-click on the application project in the Solution Explorer, and then click on the project's dependency order and make sure that the correct project is selected. Then right-click on the library's Projects x64 folder and delete it, in both debug and release modes. The folder is not deleted, but it does seem to tidy things up and all should now be well. I think we covered the most important aspects in a very generalized view. Thanks for watching, and I'll see you in the next video.